go ahead and get rid of that. Hello everyone and welcome to Handmade Hero Morning Edition. It is very good to see all of you bright and early here, 10 a.m. Friday morning here in sunny Seattle, Washington. I guess what I should say today is we are kind of wrapping up a little bit of what we were doing. Obviously, Handmade Hero, for those of you just joining us, is a show where we create an entire game from scratch using nothing but our bare little typing fingers, no engine, no libraries, so that we can kind of see everything that's involved in the full stack of game development, see how it works at a really low level, and basically gain a good understanding and have a lot of fun in the process too. It's just fun to kind of be able to do everything yourself and see how it works. It's just kind of got this really nice feel to it. Right? It's like doing that woodworking project or whatever that you always wanted to do. It just has this kind of great feel to make something directly where you know that you were kind of making it all from scratch yourself. If you are following along with the series at home and you have pre-ordered the game on handmadehero.org, you should have gotten a link in your email. That link has a zip file with every day's source code. Today's day 35, so if you want to follow along, unzip day 34 into a directory and you'll be exactly where I am today. And where I am today is we were just finishing up sort of making our virtualized tile map system sort of work for reals, in a sense that you can actually have sort of a large world with little sections that are stored by the tile map. That is what we were doing, and we were almost there. Yesterday we introduced the concept of a memory arena where we sort of basically put stuff into our permanent store, and I'd like to go ahead and sort of dive back into that today and kind of talk about it a little bit and sort of talk about how it's working and where it's going. All right, so let's go ahead and see where we were at. I'll just load up the code here and run the old game. So we basically didn't have a chance to actually make a world at all. We only had a chance to kind of slap down some stuff. So maybe what we should do before we do anything else is just kind of make it so that we're actually making some rooms for our little guy to be in. That's something that seems like a pretty reasonable thing to do, I would say. So let's go ahead and try that. So on startup, basically what happens is we have this thing that was looping over 32 screens by 32 screens, and then it was just kind of setting tile values, and it was setting them totally randomly. So what I might like to do is just set some walls in here, and so maybe I'm going to go ahead and say that whatever the tile value is, that tile value will default to be nothing, but if the tile x equals 0, let's say, or the tile x equals tiles per width minus 1, so if it's on either edge of the screen, we are going to say that the tile value should be 1, so there'll be a blocker there. So that's basically making our horizontal walls, and then we can also make our vertical walls the same way, essentially, and this should make rooms, I think, oops, I've got to actually use that tile value. This should make rooms, I think, that are sealed, right? It should make rooms that we cannot get out of, that we're kind of just stuck in. And there you go. We can't actually get out of them. And you can see that this is kind of like a room like we used to have, right, this sort of thing. But we don't have any doors yet. So all we kind of really have to do here is make some doors. So let's go ahead and make some doors real quick. How do we want to make doors? Well, I guess in here we'll say that if the tile y equals tiles per height over 2, then we don't want to make the door then we do want to make the door, and if not, then we don't, and the same will be true for our tile x, right? If it's going to be tiles per width over 2, then it's right in the middle, so we'll make that door, and I think that should basically make doors for us everywhere so that we can, if we want to, walk through things. Now, we should basically have sort of this really, really large world, and of course I can speed sort of through it. We now just have room upon room upon room of stuff in there with nothing in particular going on or happening in any of these rooms. We should be able to get to the end of it. We only made, 32 of these. How many did we make? I don't actually remember how many of these we made. 32. So if we walk 32 of these forwards, which is a lot of them, we would eventually get to the end. But I don't think I'm going to sit here and do that. So anyway, that makes rooms and rooms and rooms and rooms for us to go through, which is all well and good. Excuse me. But now what we want to do is we want to make it so that maybe we basically have only rooms, we don't have just a full grid. We want to start testing our sparseness. You know what I'd like to do too? Actually, let's do this as well. Let's actually try something here just to see what would happen. Let's actually try doing something that will totally tank our frame rate probably because of the slow way that we've done things here, because we're just kind of looping over everything. What if we were to go ahead and actually make the tile size much smaller and draw a lot more of them? So for example, up here, remember the thing that determines how big our world is, we have our tile size in pixels, right? We have our tile size in pixels here and our meters to pixels. If we were to make the pixels extremely small, let's say we were to be able to fit 10 times more of them in there, so we made our tile size in pixels be only 6, right? We could go in here and we could query a lot more pixels. In fact, you can kind of see what happens if I just do that. You notice we're just drawing a very small version of our tile map. Excuse me. And so now the question is, what could I do? Could I go in there and basically just draw a much larger version of the map? So to do that, I just have to actually pull more, and we'll want to be doing a lot more stuff than we're doing here. Obviously, these are just debug drawing routines. But anyway, if I go ahead here now, again, this is really inefficient what we're doing, but you can see that we basically have our entire map being drawn now. Well, not our entire map, but a much larger version of it, so we can kind of see what's going on. Now, what I would like to do, I guess, at this point, is say if a section of the tile map was not initialized, so there isn't anything in it, I'd like to draw that in something other than gray, just so that we can see it, or rather, have some way of knowing what it is. Because right now, when there's nothing in the tile map, we just return 0, and so you can kind of see, for example, that I'm like kind of off in space there. So maybe, I don't know, one thing that we might want to do is start to talk about is there a concept of an invalid tile, so we can kind of see where our tile map just doesn't have anything. Because out here, there was nothing. We didn't initialize it. But we're just returning 0 whenever we look for a tile chunk and don't find one there, right? So what I wanted to do is kind of say, all right, well, maybe, if the tile map comes back 0, right, let's say that we basically have something where we get the tile value, and if the tile ID is going to be greater than 0, so 0 will actually mean there's nothing there at all, and we just won't draw anything, right? Now, unfortunately, so far we've had 0 in our tile map. 0 has meant nothing. Excuse me. 0 has meant that it was walkable. So I'm just going to go ahead and arbitrarily, because I can, and we haven't thought about this at all, obviously. I'm going to go ahead and set these to basically be 1 and 2. Eventually, we're going to have to think about what we actually want to store in our tiles. But right now, I'm just randomly slapping number codes in there, completely willy-nilly. So I'm just going to go ahead and do that. So now we have 0 means there's nothing there, 1 means it was walkable, 2 means that it was a wall. And so I'll go into the tile map now, and all I really have to do is that isTileEmpty thing. And this is a good example of why we'd want to start having enums for these. But this code's, these tile storage is not really going to be how we're ever going to store tiles. Really, we're going to have a lot more data than in a uint32 probably, so it's not that interesting to start defining enums and stuff. But I suspect now, there. So now we can kind of see what's going on, right? We can see that there's nothing in the world out there. We haven't actually defined a tile chunk for those locations, because remember, this down here is 0, 0. Actually, we started the guy out pretty close to it. So back here is like some really high number. This is like 4 billion. That tile is 4 billion, 4 billion, right? Because the world is toroidal, like I said, it wraps around. And so now you can kind of see roughly where we have defined the world and where we haven't. And so that's kind of just a nice sort of thing to kind of understand, if that makes sense. So going through here, what I am now thinking we should do is we should actually only make rooms in some places. Now what I'd like to do is start talking about random numbers, but it might be a little premature. Again, this is a place where we could lean on the C runtime library so that I don't have to teach random numbers just yet, and we could still have them, but we would like to have some way of making, oh, you know what? No, there's an easier way to do random numbers that doesn't involve me leaning on the C runtime library that we can do. Okay, so there you can see I walked to the end of it. We've walked 32 up. So there you go. So what I'd like to do now is maybe do something where we kind of have a random a random number sort of thing that happens. What I'd like to do is basically say, okay, before what we were doing is we were doing something where was I? Handmade.cbp. We were basically just looping over the screens 32 by 32, and we were just making a new screen. What I'd like to do now is just say instead, I'm going to do a number of screens, right? I'm going to do screen index equals 0. I'm going to do screen index less than 100. So I'm going to make 100 screens, but I'm not going to say where they are. So we'll start out by saying that our screen X and our screen Y are at 0, 0, but instead of looping over it, I'm just not going to say where the screens are. So we're going to make a screen at the location that we're at, but then we're going to choose to move to a different screen based on some kind of random number, okay? Okay. Sorry, I just took a look at the screen, and I noticed people talking about the art. And yes, I'm excited to get to the art. That'll probably be happening very soon now. I just had a bunch of stuff I kind of wanted to go through with you before we start dealing with the renderer. But yeah, the artist for the game, Yangshin Lee, is awesome. I'm really, really glad that she was interested in working on the project because her art is fantastic. Yeah, the stuff for the game has just looked absolutely gorgeous. So I think the game will look absolutely beautiful. Yeah, I'm glad you guys think so as well, because I thought her stuff was really, really quite fantastic. Anyway, moving on. So here we are. We're going to do this number of screens. So what we'll do is we'll lay out the same thing we did, just a room with some doors in it. And then what we're going to do is say, okay, from there, I'm just going to randomly move one of the two. I'll either increment screen X or I'll increment screen Y, but not both of them. So I'll basically do like if random number, something like this, equals 0, like that. Or I should say, if random choice equals 0, else do this. So we'll do screen X plus equals 1, or screen Y plus equals 1. So we'll just kind of go in whatever direction that is. And so now we just need a way of making a random choice, right? We need to be able to make a random choice somehow so that we can get something that allows us to pick randomly whether we want to go to the right one or up one, right, with our room. So we're going to start out, we're going to make a room, then we're going to choose to either make a room to the right of it or the room above it. That's all we're doing here, right? Very, very simple. So what we'd like to do is figure out how to make a random choice. Now, normally the way random numbers work, and like I said, we won't really get into random numbers just yet. We'll be making our own random number generator once we actually start doing the world generation stuff for real. But at the moment, I just need something so we can kind of splat down rooms in a random pattern and start to see how our sparseness thing is working. So what I want to do here is just sort of point out the fact that, okay, random choice, what I need to do is I need to take a random number and I need to produce one of two options. And so the way that that's typically done is using the mod operator. Now the mod operator, as we've talked about before on the stream, is basically something that does a divide and just talks about the remainder of that divide in integer space. So if I divide something by 2, I know I will either get a 0 or a 1, because the only remainder you can get when you divide something by 2 is 0 or 1, right? That's all that's going to be left, assuming we're talking about positive numbers here. So if I take a random positive number, I divide it by 2, the remainder will either be 1 or 0. It can never be 2 because then we would have had 1 higher when we did the divide, right? So the mod operator is something that takes some random number and turns it into a number of choices for us, and that's exactly what we wanted, right? So all we need to do now is do some random number here. We need to have a way of doing a random number. And what I'm going to do is just avoid the issue altogether for the moment so we don't have to start talking about random numbers today because it's not really a good time for it. We want to spend kind of a week talking about them or something at some time in the future. Maybe not a week, but at least a couple days. So I'm just going to have our table of random numbers for now. And then I will just put in to do here. Our random number generator will be something that we'll want to actually do a good job on. Since this game's procedurally generated, we really want a good random number generator, obviously. So what we're going to do is just do this. And I'm going to say that we essentially have a random number table here that we can initialize with a bunch of random numbers, and then we'll have a random number index, and that random number index will start off at 0. And I will also assert here that the random number index is less than the array count of the random number table, and we'll just make sure that we make a big enough random table to have all the randomness that we need for now. Again, not a particularly glorious or beautiful solution, but that is just what we have to do to get things started. So there's our random number index, and now we will go make our random number table out here, and that can be a internal global. There is our random number table, and our random number table, we can now just go grab a ton of random numbers. I guess there's a easy way to do this on random.org usually. I feel like we can typically get them in different formats as well. Where is it? Lists and more. No, numbers, integers, integer sets. Here we go. Switch to advanced mode. We want hexadecimal. We want values between 1 and 4 billion, ideally. Actually, I guess they could even be 0. We would like to generate, I don't know, let's get at least one full 4096 load of those, maybe. We could even get more than that if we wanted to. I'd like 4 billion in here to be the largest, so let's go ahead and actually get the exact 4 gigabyte number, 4 times 1024 times 1024 times 1024. So I'd like that to be the largest. There we go. And we can go ahead and format those in 8 columns. So let's see. Bare bones text documents. Let's see. Get numbers. Oh. Seriously, guys? Seriously? Alright, fine. Yeah, that's right. 1 mil. Alright. Why is that? I have no idea why that would be. But let's go ahead and just accept our limitations, because again, this is only a temporary solution. So I guess that'll be fine. We've got all our stuff in here. Get numbers. There we go. So there's our random numbers, right? They're lovely. They're a little smaller than I would have liked, but I can go ahead and cut and paste those in here, and now I've got some entropy. And entropy is always kind of good. So now I will go through and just format this in a way that actually would allow us to compile it. This is a good case for, again, the C macros. So let's say that we have something that looks like this. I will go ahead and start my macro recording. I will come out here, delete that, put a comma in there. Come out here, delete that, put a comma in there. Come out here, delete that, put a comma in there. Oops, that's no good. Let's try this one more time. I'm not doing very well today. Not a good editing day, people. Not a good editing day at all for Casey. Alright. This might still work, though. No, it doesn't. Let's try that one more time. You know it's a good day if the keyboard macro goes right the first time, and you know it's a bad day if it don't, right? Alright. So let's try that again. Do this, forwards, comma, oops. Wow, it's like I can't even type. I don't know what's going on, people. I do not know. All right, let's try that one more time. How hard could it be? You know? Really. Shouldn't be that hard. I'm being completely silent here so I don't mess it up. All right. Okay. There we go. Oh, you know what I forgot? And I forgot to put the OX in there, so I'm going to have to do this again. So you'll get to see me make another keyboard macro where I'll probably mess it up. So, you know, yeah, not a good editing day. Maybe it's because it's Friday. Maybe it's because it's early in the morning. Maybe it's because the coffee has not kicked in yet. I'm drinking coffee almond milk this morning. Homemade. Quite tasty. Yeah. What can I say? I like me some almond milk. All right. So let's go ahead and, you notice how slow Emacs is doing this? It's kind of crazy, you know? Call of Duty can render 30 or 60 nowadays photorealistic frames per second. Emacs can't apply a keyboard macro in less than a second. Kind of amazing, ladies and gentlemen. Kind of amazing. What are you going to do? What are you going to do, people? Add new editor to the list of things I got to do in my life. All right, still going here. God, look at how it's so slow, and it just gets slower and slower and slower. Absolutely awful. I do not know how they ended up in such a place. Look at how slow that is. How much more of these do I have to do? This is going to take forever. It's never going to finish. Ugh. All right. Let's see what I can do here. I wonder if there's something I can do here that would speed things up. Maybe it's because I hit the... will the comma automatically tab it? Yeah, it will. I expect it's probably the tab that's super slow, too. Yeah, that's really unfortunate. So what happens here when I do that? It doesn't actually do the... Okay, so let's try this one more time without me doing tab at the beginning. So we'll do define keyboard macro. I'll just do ox, go, comma, delete, space, ox, comma, delete, space, ox, comma, delete, space, ox. I probably could have told you how to make a random number generator and the amount of time this took. Ox, right? You know, it's like, welcome to absolutely horrible editor performance. You wonder why I say, you know, a lot of people ask me why I use Emacs but don't recommend it. It's because, well, I'm used to it, and it's hard to find, it's hard to take the time to switch to a new editor, but it's stuff like this that's just absurd, right? It's like, this should be instantaneous. There's absolutely no excuse for this not being 100% instantaneous. But of course it's not. You know what I could probably do too? If I switch to text mode, I bet that'd be, yeah. It's the C++ indentation feature. There you go. C++ indentation apparently is way too much for Emacs to handle. So there you go. That's the money right there. Now it's like totally instant, right? That's so sad. But yeah, what are you going to do? What are you going to do? Emacs Lisp, not the most performant thing in the world, people. Let that be a lesson to you. All right. So there we go, and I'll turn back on the C++ mode eventually, but now we can actually do things at least that are somewhat fast, so I can go ahead and finish this guy, define the keyboard macro for this, just like this. Man, that was ridiculously bad. Just so awful. All right. There we go. And now I can go ahead and just kind of finish those up. Like so. Like so. Okay. There we go. Now we have our random number generator, and I can actually turn C++ mode back on so we get our proper indentation. And I don't obviously want that polluting up our source file, so I'm just going to make a handmade random .h for now, and we'll just stuff that in there and forget about it, right? And so now we've got our random number table sitting there doing its thing, and I'll just go ahead and have Emacs take the incredibly long time it takes it to indent. Look at how long it takes to indent that. Look at that. It's just crazy. 34% complete. There has to be a percent done indicator to indent 500 lines of code. Ugh. The pain and suffering. How is it possible, people? Look at this. So embarrassing, right? Just so embarrassing. I reported this, by the way. Well, actually, a viewer actually was reporting this. A Handmade Hero person, when I was complaining about how slow Emacs is, I sent them a file where this kind of thing happens. And the maintainer said, it's unreasonable to expect it to go any faster. That's what the Emacs people wrote back. I'm not kidding. I guess they just don't understand how computers work or something. I don't know. It's awful. Anyway, so here we are at our random number table situation. We got to include it, obviously. So we have to go in here and do handmade random.h, kind of put that in there. We'll deal with that later. Let's see. What is our problem here? Oh, I think, what did I actually call this? I think I just called it global variable or something like that. Yeah. So now we have something random we can look at. So what we're going to do here, like I said, is our routine now is going to do its little, it's going to basically do the same thing it was doing to make a screen. But instead, you can see when it comes in here, right, it's going to actually, after it's done, right, here's it making the screen, right, setting the tile values for one screen. After it's done making the tile for one screen, it's going to go here, it's going to get a random choice. it's going to use that to decide which one of these it does, and hopefully, it makes a different one every so often. Let's see if that's actually true. 1, let's see here, random choice, 0. Yeah, so it's doing what it's supposed to do, and then we're just going to increment one of the two values differently depending on it. And so there you go. We've now made exactly what I kind of wanted to make there. We've made sort of a random thing where we have all of our rooms kind of laid out in a random fashion, right? They kind of just go up. Now, this is not a good random algorithm for laying out rooms because it can't even double back on itself. But I just wanted something that would create a shape that wasn't a block, right? That wasn't just a solid block. And you can kind of see how that's working here. But now what we need to do is I also want to draw where there are and aren't tile maps for the world, right? I want to be able to draw locations where there are and aren't where there is and isn't storage. So in addition to uninitialized, I also want to draw, sort of see where the storage is, if that makes sense. And so what I'm going to do for that is I'm going to say that whenever we make a tile map, for now, right here, where we actually create all of our tile chunks, right here, I'm actually going to also go ahead and just initialize them all. Right, so I'm going to say that we basically have our tile count, and our tile count is this thing, right? This is how many tiles there are per chunk in our tile map. What I'm going to do is I'm going to spin over that whole set of tiles, right? So there's the tile count. I'm going to spin over the whole set of tiles, and I'm going to initialize them all to 0 so that we can see where our tiles are and aren't, if that makes sense. So our tile chunks, tile index, equals 0, right? Like that. Excuse me. 1, not 0. No operator found, which takes what? What is the problem here? What did I do? Tile chunks. Right. Tiles. It's actually this. So this is tile chunk index. Here we go. Tile chunk index, like that. So I'm pulling out each individual tile chunk. When I allocate it, I'm going to set it all to 1. And so then when you run it, what you can see is we're not storing anything sparse at the moment, right? We actually did create storage for this whole area. We're just not actually ever writing any walls into it, but we did actually store the whole area. So what we'd like to do is just nominally make this a little sparser now, just using the stupidest possible thing, so that we can at least verify that we are sort of doing things in a sparse method, and then we can sort of leave it from then on as a to-do when we're doing the engine proper to actually have a smart sparse storage for things. So you can kind of see what I mean there, right? So what I want to do now is I want to make it so that we only actually start to allocate space for the tiles when we actually need to store tiles there, if that makes sense. Instead of, right now I've got this thing which basically pre-allocates. It's basically as if we just did one giant array. It's not sparse at all. So now it's time. We've done all the work. Now it's time to actually make our tile map sparse, right? And so I'm just going to quickly, because I know this is a lot of stuff for people who've never done this before. So what we were doing, right, is we store these tile chunks. A tile chunk right now, I think we set it so that it was basically 16 on a side. Is what I believe we set it to. Yeah, that's what we set it to here. And so basically what we were doing is we're creating 16 by 16 chunks. We created, however, 128 by 128 of them. So we basically made a big block of these chunks. And each one of them basically gets filled in. So it's exactly the same as if we had just right off the bat made a giant tile map that was, 128 times 16. That was 2048 by 2048. Right? That's basically all we did, is we made a 2048 by 2048 tile map. So what we want to do now is start to store that sparsely. So the simplest thing we can possibly do here is say that instead of having tile chunks always have their tiles in them, the tile chunks just won't have the tiles yet. So instead of doing this spin over the array where we actually sort of, this right here that does this allocation to actually put tiles into the tile chunks, we're just not going to allocate them. We're just not going to do that step, right? Instead, what we're going to do is when we actually need to set a tile value, when the tile chunk comes back, if there wasn't a tile chunk, if that tile chunk didn't have any tiles in it, then what we'll do, basically say if tile chunk tiles is not initialized, we'll initialize it right there. So right there, at the time when we go to do it, we will, that is when, right? When we actually find that we're trying to set the value of a tile chunk that doesn't have any tiles in it, that's when we'll do it. And similarly, I think what we want to do is when we do a get tile value, we similarly want to say if the tile chunk tiles are there, because we want to always do that as well. There we go. Set tile value. We'll check that as well. Now, set tile value really probably doesn't need to call this this checked one here, but I don't know. Well, we'll leave it there for now, just in case. And this doesn't need to be there either. That's just some copy pasta, as people on the stream like to say. Anyway, so what we're going to do is, if we find that there's no tiles, we're going to initialize them right here. We're just going to basically do, okay, we have this tile chunk, right? We're going to do the same thing we were doing before, but now the tile chunk will be allocated just in time. So as soon as we try to write into a tile chunk that hasn't had any tiles allocated for it yet, we're going to go ahead and say, make those tiles right now, push them onto that arena that we've been passed, which is where we're supposed to store them, right? We need to know what that tile count is. Again, that tile count value is defined by our chunk dim, right? That chunk dim, it's just the chunk dim squared, right? It's just because we're everything square at the moment. So our tile count is just that chunk dim squared. We're going to allocate that. We're going to go over the tiles, and we are going to go ahead and fill them all in with 1, right? Makes sense. So that's all I'm going to do. That's it. Nothing particularly tile chunk. There we go. What's the problem? Push array, right. So now we actually have to loft that arena stuff up a little bit because I had just kind of declared it right where it needed to be, but actual people are starting to use it now. So this stuff, I'm just going to go ahead and pop that up into here so that everyone can use it who wants to use it, like that. Excuse me. For now, we'll have to, this will probably become its own file because we'll have our memory stuff in there, but for now, don't need to worry about that. And now we can actually see ourselves storing stuff sparsely. So now you can see that basically we're not storing the tile map everywhere in a giant rectangle. We're only storing the tile map around the places where we actually have rooms, right? And so that is much nicer and uses a lot less memory. So now we can have much larger worlds in terms of span, and we won't pay for a bunch of space that forces the storage for them to be rectangular, right? To be a giant rectangle. Does that make sense? Hopefully you can see what I did there. So now we're only storing the places around, we're using 16 by 16 blocks, so there's still some wastage, as you can see, because it has to be aligned on the 16 by 16 blocks, but we now have a nicely sparsely stored world that only exists sort of in the places where we actually needed to write data, right? So that's pretty cool. That's good. So we've gotten to the place that I wanted us to be for our tile map storage. We are now storing it sparsely, and we can store very large things. If you can imagine, like, yeah, basically, we can, you know what, we can even go ahead and say now, if I go back in here, handmade.cpp, you can see how this kind of feels. You would never actually know that this is the case if we did a couple, the player will never have to know that the world doesn't exist outside the part that they can see. So what we could do, for example, is when we make our doors, let's go ahead and make our random choice sort of at the head end. Let's just move this up here. So basically, when we come into the screen, we make the random choice about which it's going to be, and then we basically say, okay, if we were going to go one screen over in X, because we're making doors on either side, right? So basically, what we need to do is we need to basically say where the doors should be, and so we can sort of do something where we basically say, is there a door? Is there a door on the left? Is there a door on the right? So on. So we'll basically say like this, door right, door top, door bottom, something like this. And so what I'll do is I'll set those out here so that there's no doors to start with. When we make the random choice, we will be determining whether there's a door in one of those places. So we'll say, if the random choice equals 0, else, right? And so what did we say? We said that we go 1 to the right. So there's a door on the right in the case of this, right? There's a door to the top in the case of this, right? Then when we get to the bottom, we'll clear those out, right? We'll clear all of these back after we're out of here. So after we finish making our doors, we'll clear all these out, right, like that. But instead of clearing them to 0, what we'll do is we'll say, well, the door to the left is where the door to the right was on this screen, and we want it to carry over so that the next screen, if there was a door to the right here, there'll be a door to the left on the other one. So we're just going to say that basically door to the left is whether there was a door to the right on this one, right? And we're going to say that the door to the top is whether or not, door to the bottom is whether or not there was a door to the top on the other one, right? So, because those are the two doors that would be determined by the previous thing. And then we're going to say, that the right and the top doors are cleared out, because those are going to get set up here. Okay. So I'm just doing it that way. I know it's super janky and weird. Again, I'm just trying to make something real quick. This is not, again, please do not make worlds this way that I'm doing them. We will be doing a lot more interesting stuff later with that. This is just something to kind of get us going. So, here we are in our tile stuff. What we want to do here is say, basically, we've got each of these is going to be a separate case now, right? And again, this is a little bit piggy code, but that's okay. This is only happening on startup. There's nothing particular to worry about here. There we go. But basically, this is just the same code. There we go. Just doing a cut and paste reuse, as it is called, quote unquote. And so now, basically, if the tile x is 0 and the tile y is half, that is going to be, and in fact, we can kind of make this, I guess we can basically just make this a much more concise case. We can basically just say, if the tile x is 0 and the tile y is not equal to the middle, right, then we're going to make there be a wall there, right? All right, that makes sense. And this tile x, the only thing we need to do now is say, well, if there also was supposed to be a door to the left. Otherwise, we're going to leave it as a wall, I guess. So, and if tile x equals 0, it's going, and there isn't supposed to be a door to the left, right? And that. I think, am I correct there? Am I correct there? So if there's a tile left and, no. It's not door left or. This is very complicated. I'm not sure I'm going to get this right. Let me think about this. So if we were going to draw a wall, we draw a wall if tile x equals 0, and it's not where in the middle, because if it was in the middle, we wouldn't draw it. But if it's not in the middle, we'd also still draw it if there wasn't supposed to be a drawer to the left. Because if there's not supposed to be a drawer to the left, we need to fill it in, right? Oh man, that's crazy. That is just some crazy ifing. But I think it's actually correct. I don't know. Don't take my word for it. Okay. So yeah, we'll see if it actually works. That's what we'll do. So yeah, so there's the test for the other one. Basically, this is for the door on the right. If there's not supposed to be a door on the right, or if it's in the middle, then we would put the blocker in there, right? Is that right? So the tile x, and I got to think this through one more time. In fact, I kind of almost have to make the logic table for it. If the tile x equals 0, we're going to make a wall. But it also has to be the case that we're not on that part, then we'll make the wall. Or if we're, I don't know. I'm thinking that's roughly correct. Let's just assume that it is. We'll do it in testing because honestly, that's hurting my brain to even think about that and to the degree that I have to think about it right now. So if there's a door to the top, oops. Wait, no, this is tile y 0. So this is a door to the bottom. There's not a door to the bottom, or this is not equal to middle. There we go. So that's that one. There's our incredibly stylish door bottom code, and then similarly, the tile y. This is our door top, coming out the top, and that is this. And there we go. Oops. There we go. Man, that is some ugly looking stuff right there. That is some ugly looking stuff. Let's see if it works at all. Probably not. Yeah, probably not. Of course, it works a little. It almost worked. It almost worked. But we've got one. Our door to the top code is busted somehow. What did I do here? Let's see. Door top. If tile y equals tile right minus 1, and it's not the door top, or tile x is not equal to. There we go. I forgot my not equal to there. Hey! So there we go. Really surprised that worked, but there you go. So now we've actually got doors that only lead to where the rooms we actually made were, which is kind of a nice thing. So that's all good. But basically what we want to do now is we want to say, okay, since we've got that, let's see what happens if we drop the player actually into sort of the location more for real. So if we actually go here now and cut this back down to doing what it was doing before, so we're only kind of drawing right around the player, and I change back to doing sort of that close in view. So now you can imagine if the camera was locked in here, right, if the camera is like that, then really the player would never actually know that we're not storing the world outside it, right? Because they're never actually going to see anything other than this, so they're just going to think that the world exists everywhere because everywhere they see it does exist, but it really secretly doesn't, basically outside of that sort of area. Now, of course, you can still see it now because we allow the camera to kind of roam over there, but we could even fix that if we wanted, if we were doing smooth scrolling and wanted to allow the camera to move all the way over here. All we would have to do is make sure that we made an apron around all the rooms when we were basically setting the tiles, so that we make sure we actually fill out to however far over they could get to a wall. Make sure we always have some stuff out there for them to look at, and then even that would work. So basically there's no real downside to storing it sparsely. You can always make sure that everywhere the player could have seen, you actually set some tile data, and then you're good to go. The other thing we could do, if you didn't even want to do that, although I think you would want to do that so you could control what was out there and make it look reasonable, is you could also make it so that when you find that there's nothing there, when you get to a place where there isn't anything, instead of just drawing nothing, you just draw some random stuff that would fill it in, right? You draw in some fill-in stuff there. You could do that as well. So now we're at the point where we've kind of got, our tile map stuff seems to be working properly. Everything seems to be going relatively smoothly. No real issues so far. And this is already kind of a fairly large map to walk through. My goodness. It takes a long time to get through 100 screens. Oh. My goodness. That is taking a while. Oh. All right. I'll stop walking through the world now. I will stop walking through the world now. It kind of reminds me, our test code here kind of reminds me of the old Adventure. I don't know if you've ever seen that. There's like this old Atari 2600 game called Adventure. I don't know if you've ever seen it. But it reminds me of that because basically like this test graphics that we're doing here where we're just trying to show that our tiles are working and looking at things is what the actual shipping graphics on the old Atari 2600 games looked like. So if you actually go look back at Adventure, it looks a lot like this, only it didn't have smooth scrolling. It couldn't scroll. So once we actually locked the camera, then it would literally look just like this. It was kind of crazy, but that's what games looked like back then, and that was a famous game, Adventure, on the Atari 2600, shipped with graphics that looked like this, if you can imagine that. For those of you who weren't there at the time, I suppose that's probably pretty surprising, but that was the truth, and we loved it. I mean, I played the heck out of that game. I killed all the dragons. I found the black dot. What can you do? So anyway, we're pretty much done with our tile map stuff now. So if we kind of go back here and take a look at how that's working, hopefully everyone understands roughly what we did. We just have a very simple thing here called tile map. You can define it to be sort of however size however you want. Now, one thing that I will point out is that this is actually a little bit inappropriate. This tile size in pixels and meters to pixels thing, I'm pretty sure we don't want that anymore because the tile map knows nothing about pixels and probably just doesn't want to. So what we probably want to do is get rid of that and push that over here for now, basically into something that sort of gets initialized as a separate piece, like this, because that's just not part of the tile map. That's not a relevant thing. And so what I was thinking is maybe we'd just go ahead and say that the tile side in pixels is something that sort of exists in the renderer. It's a renderer concept. It's not something that exists in the tile map, just so everyone knows that using the tile map, that's not a thing in there, if that makes sense. All of these are sort of things that are, excuse me, let's see here, tile map undeclared, okay, get rid of that, there we go, and then this is actually the tile map, so that's just going to be there. So basically I just pulled those out, right? And I'm going to make tile side in pixels be something that's just a notion in the renderer. So once there's a renderer, we'll think about where that needs to live. But for now, I just kind of want to get rid of that idea entirely from the tile map, because it's really just not an aspect of the tile map. Our tile map doesn't care about pixels. We just did all the work to make sure that it doesn't care about pixels, and so there's no point in it storing that as if it did care. It should just not be an aspect of that, so we'll pull that out. And now we're back to where we were. Okay. So hopefully that's clear to everyone what we did now. We have a virtualized tile store. It's the thing that we haven't done yet, so I can get rid of this now because we have done beginner sparseness, but basically we want to sort of have another to-do in here, which is real sparseness, which is basically to say that we still are storing an array. We're storing an array of pointers to tiles. So however big our world is, width and height-wise, right, you can kind of think of it, where's my drawing? Where's the awesome drawings I do? Okay, there we go. So we have our world, right? It's 4 billion tiles by 4 billion tiles, and we know that right now, essentially, just randomly, I set it to 16 by 16 chunks, right? So we're doing these. So one little section of the world, when we store it, maps out to a 16 by 16. But basically what we've done is we've said that however much part of the world, like right now we're just talking about this part of the world is all we made, we're doing 128 of these chunks, right, by 128 of them is all we could possibly store. Because right off the bat, we are saying that this array, the tile chunks array, we're only allocating that to be 128 by 128, right? So it's an array of 128 by 128 pointers. So we essentially have still a rectangular array, but we've just saved a lot of space because we just store a 0 in there if there's nothing, and then we store the pointer if there actually is something. And of course, that's a pretty big savings in terms of the sparseness, because if you remember, a tile is 4 bytes currently, and a 16 by 16 of those is going to be 1K. So storing just 8 bytes of a pointer instead of 1K is obviously a big savings. Well, it's 8 times divided by 1024. It's less than 1% size, so that's pretty great. But we'd want to be even more sparse than that if we can, because even if we were going to try and store a whole world's worth of that, that just would be still pretty onerous. So we're going to want to probably do real sparseness. So anywhere in the world can be represented without the giant pointer array. That's something that we're probably going to want to do just as an exercise, because there are sparse lookups that we can do that will not be doing it that way. So let's do one more thing to our tile map now. I think we could probably handle it. Not particularly difficult, I suspect, which is that we'd like to get Z in there. So maybe we'll add the ability to kind of go up and down, if that makes sense. So maybe we'll go ahead and say that we're going to have 2 levels of up and down for the moment, right? If that makes sense, we'll have a tile count Z. So we'll just have like an up and a down. I don't know why I'm doing this, but I feel like we kind of need to have an up and a down at least in there to begin with. Once we have a better sparseness, this will become kind of a non-issue, but for now, we'll have to do the array that way. So we'll have a tile chunk count Z as well. And then when we have our absolute tile indexes, we'll have an absolute tile Z also, right? Now Z is a little bit different. It's a little bit different from our X. and our y, because you can't see more than one of it at a time, really. Maybe you could see two levels of it sometimes, depending on how we want to do things, but in general, z is not the same. X and y, you see big chunks of it, but z is usually like these whole planes of play that you go up to or down to, and you're on a totally separate kind of level, and that's the traditional way that games work for whatever reason. So it's kind of handled slightly, just a little bit, differently. And so, for example, in the tile chunk position, you wouldn't have a z at all, really. Well, I guess you'd have a tile chunk z. Never mind, you would have that, but you wouldn't have a tile z, because there's inside a chunk there'd just be one slice, right? You'd never actually store a voxel. You wouldn't store like a volume for it or anything, right? So what I want to do is go ahead and add that extra layer in. So here, when it does this, we're actually going to store one more layer, tile chunk count z, that'll basically just have sort of that secondary plane, if you will. So then in here, when we are actually doing our lookups, we have to kind of start to think about that. So when we set our tile values, we're going to do these get chunk position fors, and that get chunk position fors, when we do our tile value stuff, we're now going to always be taking one more value, which is the abs tile z, right? And that's going to come in here, and that's going to get passed through to everything. So we're going to do that. That's really all we need to do here, I believe. We just do these sort of things where we do our get tile chunk. Get tile chunk takes the extra z. Nothing particularly odd there. We leave everything else the same. Again, this abs tile z gets passed in here, and can pose abs tile z. Those get passed through. Then when we're doing our get chunk position, it basically just gets passed right through. It doesn't actually, it's not a virtual address like the other things are. It's just the z plane. It's just where we're accessing in the z plane, right? So abs tile z is there. There we go. And when we're setting the tile values, again, same thing. When we set the tile x, there we go, we're going to pass those through, test tile z. And when we get the tile values, again, going to pass them through exactly the same way, test tile z. Nothing, again, just adding this extra coordinate on. It doesn't really require almost any work on our part. So tile x and tile y for setting tile values unchecked. Again, we don't actually need them here because we're only inside the tile map once we get down to this point. Same thing here, get tile value unchecked. We don't need z's once we're at that point. So really the only time we actually need the z is when we are actually dealing with stuff that is actually getting a tile chunk itself. So getting the tile chunks, that actually requires the z now. And that's also going to have to be bounds checked, because if you try to get something outside of the legal range, tile map, tile chunk count z, then we're going to prevent you from doing that. And now we just need one more accessor, which basically allows us to pack those guys in there. So again, just like we did before, you can kind of see the universal access pattern. I talked about this on a previous stream. Basically, you have the x, which is the one that adds just one as you go inside our memory. Because again, I don't know if you remember the diagram I drew, sort of that universal access pattern. Memory is 1D, so we just have a big old line, right? Oh my god, that's the worst line ever. Let's try something slightly, oh my god, I don't even know what that's supposed to be. So this is memory, it's one-dimensional, right? It just has one index into it. But now we've got something that is three-dimensional, right? We've got essentially a cube that we're storing here, right? We've got a cube. And so we've got an x, we've got a y, and we've got a z. And we're trying to store this cube in here. So the way we're doing it is we're slicing it like this. First we go along x. So this is x, right? We pack x, we pack that line of x into there. Then we go up one in y, and we pack the next row of x in there. So now here's another x, but it's the x that's one up in y, right? X, 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 x. When we get to the end of all of these x's, we go up one in z, and then we pack another row of x's by y and then by z again, right? So what that means is every time we go up one in x, we are only moving one forward in memory, but if we go up one in z, we're moving one whole x count, one whole length of x upwards, and if we go up in z, we're moving one whole giant plane's worth. So we're moving y's number of x's forwards, right? So that's exactly what this math is here. It's saying that the z is going to be the chunk count y times the chunk count x. That's how far we move in z. How far we move in y is just the chunk count x, and how far we move in x is just the x, right? And that's that packing that packs a three-dimensional thing into a two-dimensional thing. And that is exactly what we are doing there. Okay. So let's take a look here. Get tile value unchecked. Once we already have a tile chunk, I don't know why I added that. That was not necessary. Set tile chunk, those don't need it because they've already got the chunk. Once you've got the chunk, you don't need the z. So there we go. And now we're at our 5-minute warning, of course, so it's good that we're kind of wrapping this up here. Our abs tile z. So we'll get our tile value, got a rel x, rel y. What is the problem? Get tile value. That's supposed to be why does that take a test tile z? I have no idea. That was just me being super sloppy when it's anything that already has the chunks doesn't need the z. So I have no idea why I was adding those. That was just dumb. And so now we're always going to set basically our abs tile z to 0 at the moment so that we can reproduce what we had before, if that makes sense. And then get tile value. No overloaded function. Yeah, that's right. So we need to draw whatever our player's z is at the moment. So there we go. Abs tile x, y, and z. And now we should hopefully, unless I made a mistake, be exactly where we were before. But now we have the ability to go up and down if we would like to. So we can go ahead and do that if we want. We can create essentially something, if we want to, that would be a stairwell, right? And so I'm going to, again, go ahead and just continue the madness here. I don't know if we'll have time to quite finish this, but what I will do is I will say that if we decide on this stuff here, when we do our random choice, let's do a random choice out of 3. If the random choice equals 2, then if the random choice equals 1, we'll do it like this. And then down here, I'll do the same thing if the random choice equals 2, or if the random choice equals 1, like that. And so what I'm going to do is say that if the random choice equals 2, the abs tile z, basically if abs tile z equals 0, then I'm going to set abs tile z equal to 1. So this will be it'll go up from there. And otherwise, if abs tile z was already equal to 1, then it'll equal to 0. So I'll just toggle whichever one it is on that random choice too, right? And so up here, I will do the same thing. I'll say if random choice is 2, then we'll sort of take a look. This will be going up. This is going to have a door up sort of thing, and this is going to have a door down, if that makes sense. Yeah. So whichever one it was, that would be. Let's see, door up is false, and door down equals false. And so then the same thing happens here that happened before. Door up equals door down. Or I should actually say that what happens here is we don't actually know which order these kind of have to go in. Oops, did I make some kind of error with my indentation? I feel like I did. It's telling me that I did. Yeah, there it is. And I need to kind of remember what the abs tile z is for the player or for that thing as we go through. So what I need to do here is say basically if there was a door up, right, else not. So what I need to do here is say if there was a door up, then there's going to be a door down next time and not a door up. And if there was a door down, right, then there's going to be a door up next time. This, that, and finally, if there was neither, then there's neither, right? So I believe that would work. I'm not sure. But now what we should see is I should be able to get somewhere and there shouldn't be an exit to the room. Yeah. Well, actually, I don't know why that's there. That's a bit odd. What's going on there? What did I make? I've made an error in the code. We're basically at the Q&A, so I'm going to stop playing with this for a minute, but I want to see what my error is. Random choice equals 1, screen X, screen Y, random choice equals 1, screen X, screen Y, add tile Z equals 0. We're handling that case door up, door down. So why did we actually get a different thing there? I don't actually know. Oh, well, it could be... No, we should never have that case happen. We should never have a case where there's a door right and then we don't go right. You know what I'm saying about that? So that's just kind of busted. Why did that happen? Let's look at that again. Which I want to take. Sorry about that. I want to actually see why that's wrong. Like why we can't get there, if that makes sense. You know what I'm saying to you? So that was just the second room, right? That was the second room. So let's take a look at what happens in the debugger. There we go. Probably just something that I spammed down because I was going too quickly. But so here we are. We're going to come in on our second room, right? Our screen index is 1 on the second room. We pick the random choice. The random choice is 2. So we're going to have our door down equal to true. In our other doors, we should not have any other doors, correct? What's our door left, door right, door top, door bottom, door down, up, door down. Okay. So basically, there shouldn't have been a door right. So what happened? Is our door right code broken or something? Do you know what I'm saying? Like, why did we have that happen on the thing? We should always be having walls basically everywhere. So when we get there, let's, I guess, go ahead and see if we can get to basically the middle of things. So tile Y, what is tiles per height divided by 2? Tiles per height over 2 is 4. So let's go to 4 and see why we get that door there. Okay. Now we're at 4, so we come through here. Let's take a look at what happens. We say the tile value should be 2 because the tile X is 0, and we don't have a door left. You know what I just realized? Why didn't we have a door left set for this guy? Do you know what I'm saying? Because it should have set door left equal to door right, and the previous room had a door right. Something's busted. Oh, that's my awesome super typo. Yeah, I was trying to set door up and door down equal to false. I believe here. Oh wait, no, that's still right. Door right and door top are supposed to be false. Yeah, no, that's correct. That wasn't a typo. So I want to see what happened there. Why didn't our door carry over? I'm obviously just being dumb today, and I apologize for that. So we'll use up a little bit of Q&A, but I often go a little bit over just because if there's a bug at the end, I don't like to leave a bug in there. So I'd like to go ahead and find it. So let's see here. Random choice. Our random choice on screen index 0. Huh. Our random choice on screen index 0 was actually to have a door up. So that means that there should be no doors. Oh my God. I know what happened. It basically went up and down and overwrote itself. Oh man, yeah, that's right. I forgot to do if you already went up, you can't go down again. So it basically just went up and down and overwrote the room that was previously there before. Oh, that's funny. That's funny. Makes perfect sense, but that's funny. Okay, so basically, yeah, what we want to do here is say that our random choice is going to basically be slightly different. What we're going to say is if door up or door down. So if we had previously gone up or down, right? Then we are not going to allow the next move. The next move has to be lateral. So we're going to eliminate the option for it to ever do what it just did, which is go up and down again. Let me see if that makes a little more sense. Yeah, okay. So that's much better. So now we're locked in a room, right? And we need to be able to go up or down. And so really all I wanted to do there was just say like, okay, I don't know, there's some fixed location. So if tile X equals 6 and tile Y equals 6 or something like this, or maybe this is 10 or something like that, right? If we're at that tile or something, then tile value equals I guess 3. If door up. This is not a particularly good way to do this, but if door up is set, then it'll be 3, and if door down is set, then it will be 4. And then all I was really going to do is say, okay, if if at the time that the player moves on to something like this sort of thing, if when the player moves on to it, well, you know what, I don't really want to do that quite yet. So we'll just draw them and we won't actually, we'll actually handle ladders starting next week. That'll be a good thing to do. So all I want to do now is just make sure we draw them. Basically, we'll do if if tile ID is greater than 2, we will set that gray level to be that. So now we should at least see our doorway. There it is. Very exciting. But of course, when we step on it, we can't actually go into it because it's not a legal place to stand at the moment. But there we go. So I'm going to end it there. And then tomorrow, well, I guess it'll be Monday, we'll actually implement going up and down just so we can do that. And then maybe we'll look at storing things sparsely in a slightly different way, I'm not sure, so that we can have kind of arbitrary ups and downs in our world without having to only have 2 planes, which is what we have currently. All right, now it is time for Q&A. So I'm going to go ahead and start the Q&A filter. So please go ahead and preface your questions with Q:, and I will take a look at them. Please try to keep them to things that we've programmed so far. Let's not talk about stuff that we're going to do in the future or other things unrelated to what we're doing. Let's try to keep it on the code because this is the on-topic Q&A. If you want to ask questions random, like what do you think about such and such a language or those sorts of questions, do those. Come early to a stream sometime, and we do all sorts of questions before the stream. So that's, come a little bit before the scheduled time, 15 minutes or so, if you want to ask those kind of questions. And we will handle those questions then. Do you want to go over De Morgan's laws or K-maps to simplify those Boolean expressions? We can sort of point to them, but to be honest, I never do that sort of stuff. It's very rare that I actually do that. So you can see the things that he's talking about here if you want to go to Wikipedia. Basically, there's a set of things that say that a certain binary expression is equal to another binary expression. So, for example, like this is, not A and B is the same as not A or not B, right? They equal the same, they evaluate to the same thing. And so, if you have kind of hairy expressions, such as the ones that I was writing, which are kind of crazy, which are these sorts of things here, and you want to start trying to make these a little more simplistic, you can do that. I tend rarely to actually do that in practice. I almost never do. Usually what I end up doing is pulling things out into simpler, I usually let the compiler do that work for the most part, and I pull things out into names. Like I pull things out, if we were actually writing, if this code was code we were going to keep and not just test code where I was kind of just like spewing things out, typically what I do is I actually just make Booleans up here for things like am on left side or am on right side, and then I go from there. Because typically the compiler will do these sorts of things for you, and I don't find that there's a whole lot of reason to actually do them myself. I tend to try to prefer to make the expressions as clear as possible linguistically. And so when I go through and look at something like this and go, I want to simplify it, I tend to focus on the linguistic simplification and not on trying to simplify the number of Boolean operations that actually occur, if that makes sense. But if you're interested in that kind of thing, it is a good thing to mention. It's a good thing to read about. So I would say yes, as they basically said, you might want to take a look at this. Or I don't know if Truth Tables has a good documentation. Yeah, so a truth table is basically something you do where you basically make, you sort of make like a, almost like you would a spreadsheet where you have all your conditions and you start to say whether, if this condition is true and this condition is true, what's the end result of my expression, right? So that's another thing that you can look at as well. But again, I don't really tend to use those things in practice all that much. Do you have Emacs commands with Visual Studio? I have trouble trying to get those to work with Visual Studio newer versions. No, I don't have any Emacs commands with Visual Studio. My Visual Studio is just using the stock installation. I don't actually have it bound to anything. Have you already decided what PRNG algorithm you're going to use? I think so, but I'm not 100% positive, but I think so. We'll see when we get there. As you put the time-lapse in 3 dimensions, could this be related to a voxel octree algorithm? Probably not, and the reason for that is that voxel octrees are optimized for when you want to look at all 3 dimensions in the same way. So an octree is very unbiased. It's basically, if you're storing things in an octree, basically what an octree is, for those of you who don't know, an octree is something which basically says, I have a 3-dimensional volume, and what I'm going to do is I'm going to start dividing that volume into 8 sections, right? So you can imagine basically planes cutting my volume. I don't know if you can understand this diagram, kind of like into a Rubik's Cube, kind of way. So that now every time I want to, I take that volume, I divide it, and I end up with 8 cubes that are all 1/8 the size of the original cube. And if I want to, I can then make again, another division for any one of those cubes that I want to make higher resolution. I do it again, and so on. Now, those are interesting algorithms when you know that you're filling the space relatively uniformly in all 3 dimensions, meaning there isn't a bias in one of the dimensions that isn't getting filled as much or something like that. It makes sense to have something like an octree. And similarly, it makes sense to have an octree when you're viewing things fully in 3 dimensions, so you're as likely to be looking at things in Z as you are as in X or in Y, and so on. We don't really have that circumstance. For our game, we're looking at a game world typically, and we may, depending on how we decide to do it, I don't know how our game will shake out, but at best, we'll only be looking at probably 1 or 2 slices of the world. Like maybe if we have the guys here, and there's sort of like a cutaway, and you can sort of see what's maybe below you a little bit, or something that you're looking down into a lower part of the dungeon or something like that. Maybe we're looking at 2 or 3 slices tops. So that's 3 levels of Z or something like that might be getting viewed, whereas we're always looking at least 17 wide by 9 wide in the other 2 dimensions. And there's a lot more fill in those dimensions. Like we typically won't have a 17 high stack in Z. We'll probably have a 10 high stack in Z where dungeons are or something at most, whereas we're going to have thousands wide stacks potentially in X and Y depending on how big the overworld map is and that sort of stuff. And so an octree is not a very good choice as a way to partition our world, I don't think, because it's sort of doing a lot more work to get you benefits that we will never realize. An octree is more like if you're making Minecraft or something, where you're looking and you're trying to build the world that you're doing a lot of up and down traversals, and you're looking at big mountains and stuff like this, where you're trying to have kind of that fully 3D thing. But for a 2D game, they just don't make a whole lot of sense. So we will probably not be looking at a voxel octree type structure because it wouldn't really do much for us. It'd basically be giving us a lot of power that we would never use. And there's always a cost to that. Is there a reason of chunk size to be a power of 2? There is, and that is because the thing that we were doing, the trick that we were doing for the lookup doesn't work if it's not a power of 2. So if you look at the way we were doing the lookup, it's here, right? What we're doing is we're using a shift and mask to split out the values. And so we can't do that if the chunk size isn't a power of 2. Now that doesn't mean that the chunk size should stay a power of 2, because it may be that this operation just isn't that interesting and we can do it with a regular divide. Because if you think about it, if we wanted to do this, all we're doing is essentially doing a divide and remainder. This is a divide and remainder operation. And so basically divide and remainder, if you think about it, right, right now we have a 428 is our number, right? We set it so that it's 16 by 16, so the bottom part is 4, the top part's 28. What we're doing when we do the shift is we're taking the whole number part, which is the 28, and that's our chunk, right, index, and we're taking the remainder, which is the bottom part, and that 4 is becoming the tile inside that chunk, right? What we could do if we wanted to have an arbitrary one is we could just do a divide and remainder, right? So instead of doing shift to get this guy and mask to get this guy, what we could actually do is to get this guy, we could do divide. We do divide by the dim, right? And that would get us the top part, and it could be any size we wanted. So we could, if we wanted to have it be aligned to our screen size, we could do, divide by 17, let's say, and then we could do mod by 17, and that would get us our tile index. So we could, if it turns out that storage is the most important thing, and that this operation doesn't actually have to be that fast, we could very well go with a scheme like that. And that's something that ends up being a determination to be made when we're actually implementing the engine and performance tuning it and stuff like that. The important thing is, at this stage of the game, is to try and not do things that would preclude us from making those choices. And I don't think we have really done anything like that yet. When do you use define instead of global variables? Entirely up to you, really. There's no particular right or wrong answer to that question, but there are actual differences between them, and it's important to be aware of those differences so that you make the choice that you want. Obviously, anytime that you have something that has to be, to take parameters, it has to be a pound define, certainly, but if you're talking about something like this, like pi32, that could be either, right? It could be that, or it could be defined like this, right? You could do either of those two things. I personally pretty much always use pound defines because I don't really see any reason not to, but you do lose one thing there. You gain one thing, which is that it doesn't have a type, meaning you could, for certain circumstances, like let's say, to give a very straightforward example, let's say you had something like that. The 4 can be used in pretty much any circumstance now. It doesn't matter, it's not signed or unsigned, for example. It's just 4. Whereas if I did something like this, now it really does have a type, which means that the uint, if it's used in a circumstance where a uint32 causes something bad to happen, I can't use this anymore. I have to cast it or something like that, right? So the downside, the upside of using a pound define is that there is no type to the thing that you're doing. It's just the expression, and it gets inserted in there directly, right? However, that could also be a downside. If you want it to have a type, meaning if you want it to only be used in a circumstance where you have a uint32, sometimes you can do that, like in this case where we've got a floating point suffix, it kind of gives it a type. So you can do it that way, but sometimes you can't do that. Like if you wanted the thing 4 to have a particular type, it's hard to make that happen. If you wanted it to only be an 8-bit type for some unknown reason, that's a place where doing global variables can help you, because it means that it does have a specific type. So if you wanted that, that's the reason why you might do it that way, right? There aren't a whole lot of other reasons, but your mileage may vary. Why are you using inline in variables? I have no idea what that means. I'm sorry, Subluz. We are not using inline in variables. There are no variables declared with inline. So I'm not sure what you mean by that. Why not use bit flags for doors and such? Well, the reason is because we haven't gotten to tile map storage yet. We're just using that number just to be totally clear, this number is just a total, so this will be, you know, real structure for a tile. Right now, we're just using that number to test the tile map stuff. But we have no idea how we want to start tiles yet. That's going to be completely dependent on what we want in our game. So it's not going to be a bit flag or a uint32 or anything like that. It's going to be something more complicated. Why would you prefer an array of tile chunks instead of a door entity which links to a tile map? So the reason is because we may want to view them. So like I said, I wanted our world to be consistent and to feel consistent. So I'll show you the difference between the two cases. So what the person was suggesting is when we have a door, right, why don't we just make that door point to some other location that you go to when you enter the door, right? Instead of making there be a three-dimensional tile map where you go up or down based on that, right? And the example is, and then another one would be, you know, why do I have a door with tile chunks on either side where we basically can walk through it? Why don't I just have it so that the tile map basically just has a thing there, and then the other one has a matching thing, right? And they just teleport between each other, right? Why not do that? So why not just use teleporting when you walk onto something instead of actually making a continuous tile chunk world? The answer is for two reasons. The simplest one is that I want to be able to do things anytime I want that involve a more complex display of the world. So for example, if we wanted to zoom out on the world for some reason in the game and show a larger window on the world, this scheme doesn't work, right? Because as soon as you try to show more than one room at a time, now you actually need to know where they are spatially related to each other. You can't just have teleporters that teleport between them as if they were doors and the player doesn't know the difference, right? So there's that. The same is true, for the exact same reason, it's true for up and down as well, because like I said, we may want to have a circumstance where like you're walking up here on something, right, and there's a hole in the floor, and you can see down below you to the lower level tile map. Again, having a teleporter is not going to help here because in fact there isn't actually a connection between those. You can't actually get there. Like you may not be able to walk down there. You may just see it, and then the actual way you get down there is like somewhere else, right? So we always want to be able to query the whole world consistently so we can show things. Similarly, we want to know some stuff. For example, we may want to do things that involve the geometry of the world. Like let's say, just to give you a very simple example, let's say that we wanted to have something that breaks through walls. So for example, let's say we want to implement a boss monster who can shoot through walls and they bore a hole in the wall. Well, that's incredibly difficult to do here because when they bore a thing in this wall, you have no idea where that was supposed to go. You would have to annotate it or something and say where it was supposed to go, or you'd have to search for the nearest portal, figure out where that portal goes, and assume that the things next to it are that, right? So it's really limiting to do this. You never really want to do this if you can avoid it. Teleporting as a means of moving somewhere in geometry that isn't really a teleport is usually bad. The only time you want to do teleporting is if it's actually teleporting. If there's a portal here that's supposed to go to some totally random portion of the world, that's a perfectly good case for teleporting, and we may well have those. But you never want to teleport for something that's actually geometric movement because then it constrains your game design in all these ways that are kind of not that good, right? Another example would be sound. Let's say I'm in this room and I want to hear the fact that there's a boss monster in this other room. Well, it's pretty easy to propagate sound, right? And so like if the monster was walking here and I was standing right here and I'm listening through this wall, right? Let's say in fact there's no door in the wall. Maybe it's like a solid thing. And there's a boss monster here and I'm here. Well, I want to be able to propagate that sound through the wall. But I can't do it if my whole system is based on magic portals because I have no idea how these rooms are connected. So hopefully that gives you a good set of reasons of why you typically want things to be geometric and be able to query them in a very geometric way. And so our tile chunks are a way of virtualizing the world so that we can still always query it geometrically if we want to, but we can also make it be very huge and sprawling and not have to worry about making it be one giant array. Are you following Robert C. Martin rules? Sorry, I have no idea who Robert C. Martin is or what his rules are, so I suspect we probably are not. but I do not know what those are. Are we planning to unload the tile chunks on demand, or will the entire world map stay in memory? I'm thinking it'll probably stay in memory, but we could unload and load them. I don't know. What you'll notice is it would be trivial for us to do load and unload, because really all we'd have to do here, we basically set ourselves up for success there. Right here, if the tile chunk were not found, we could page it in right here if we wanted to. Now, there are reasons why you don't quite want to do that exactly that way, but because of stalling and stuff. So we'd do something a little more complicated if we were going to page in and page out. But you could basically see that paging page in and out would be pretty much free. And when you did the page in here, you could just go find the least recently used tile chunk and page that out. So you could change, it would literally take like 30 minutes to change what we've got here into a demand paging scheme. But I don't know if we'll ever actually need to do that. How much of this code will get used in the final procedural code of the game? It looks very complicated to make any changes here linguistically. Are you talking about this code here that just does like none of this? This is getting deleted as soon as we actually start doing world generation. But I just needed something to spam stuff out into the world so we could test our tile map code. So this is just garbage. It's complete garbage. If it helps, I can put it to do there for you. Because this is total garbage. We won't be using any of it. Are we planning on making the tile map layered, graphics, physics, logic, etc.? Well, I don't know if it'll be layered, perhaps in the way that you might be implying that in terms of like we won't be storing separate tile map chunks or anything for the different systems, but we will be having data in the tile map that's designed for use by different systems. Like the graphics part will be different from the physics part, probably. I just don't think they will necessarily be separate. They'll probably be kind of merged together. Am I listening to something, or is it just to hang the mic? It's just to hang the microphone. Well, and also so that I can hear our game sound once we actually start playing more sounds in the game. Why are primitives declared like bool32 and uint32 instead of just bool and int? The reason is because basically I like to insulate myself a little bit from the platform in the sense that I like to basically define my own types so that I can switch them whenever I want to. That is sort of a holdover from the old days when these didn't used to be defined in C. You didn't used to be able to have types in C that were a particular size. So you always had to do it yourself, and that's where I got in that habit. And I don't really like putting the underscore t on there, so at this point it's just basically to save me from typing underscore t. But for bools, the reason I don't use the actual bool type is the actual bool type has semantics I don't like. I actually want my bool to just be an integer so that it doesn't have to convert to true or false all the time, which can have performance implications. So that's why I don't use the bool type. But the other type is just force of habit, really, because nowadays you could just use these and be okay. Let's see. A lot of questions that are not related to the programming, so I am skipping them. If we're using sparseness because we're worried about the size of the tile map, would it make sense to go further and think about compression? It might. Again, that's something we'll have to determine. I suspect it probably won't, because I suspect that the sizes of our world will not be that big compared to the sizes of the art assets, and so compressing the tile map probably wouldn't really get us very far, because basically our assets are probably going to be huge, because we have so many bitmaps and stuff. So I suspect it wouldn't make sense, but if it turned out that the tile map was creating memory pressure that we were worried about, then yes. How computationally intensive is the sparse storage, and does it become more intensive as you get more sparse? So yeah, the problem, basically the trade-off with the sparse storage is specifically that there is a computational complexity there that you are paying, because if you think about what happens, and this is a very good question. I'm really glad that you asked that question. Thank you, Ridecar, too. Basically, what happens with sparse storage is, if you think about it, if we want to do a 4 billion by 4 billion world, and we were able to just flat out store it, right? And one of the sad things is, if you actually think about this a little more carefully, you realize that we could actually just store it if we had more control over the memory management unit. We could actually just map a range of memory that was reserved but not committed, and then only commit it once we actually go to use it. But there's a lot of reasons why that's very hard to do, and it's not very portable. So really, OSs are lousy is really the reason why we can't just flat out use a regular accessing scheme. It's really lame, and I hate it, but that's the truth. And so maybe like on the Raspberry Pi, we literally will just be able to do a straight mapping. It wouldn't be 4 billion by 4 billion because I don't think that's 64-bit. But if we ever do a homebrew that's actually a 64-bit, we could do a straight mapping of 4 billion by 4 billion and then only fill in the parts we want, and then we would pay almost no computational cost for it. So OSs are lousy. Windows kernel doesn't care about you. Doesn't care about you is one reason for this whole thing. But basically what we have to do is we have to implement that virtualization ourselves. And so to implement that virtualization, instead of just letting the MMU do it, well, we have this 4 billion by 4 billion thing. We would like to be able to just do that direct access, and the direct access would just be, basically a multiply, an add, and a memory lookup, right? It would be y times width plus x. Or if it's a little more complicated now, it's z times w times h plus x. This is a constant, so you're basically talking about 2 multiplies, 2 adds, and a memory lookup. Extremely efficient. You're never going to notice it, right? That's how you would get a tile. Instead, what we have to do now is we have to do that shift and mask scheme to figure out where we're getting it. We got to go pull that tile out, see if it's there, and if it is there, then we do the access, and that's a lot more expensive, right? I mean, you're probably talking about literally 10x the work because this is just so simple to do that even though there's not a whole lot to do in the sparse storage, it's still going to be, no matter what we implement, it's still going to be a bit of nastiness. So yes, the reason that we do it is because we want to have large worlds that don't have restrictions on their dimensions in sort of like they can be kind of long and skinny if they want to be and that sort of thing. And so we are paying a real cost there. And the better we do at sparsity, the more closely we map the sparseness of the world to the storage, the more expensive that sparseness does become. And so it is a real cost, and it is something we're thinking about. I'm hoping it's not going to hurt us too bad on this particular game, but it's definitely the case. And so, yeah, it would be way better if you didn't have to do it. Let's see. I'm just going to click. There's a lot of questions. I'm going to see. I'll maybe take 5 more minutes just to see if there's any other questions that are about what we were working on the tile map. Let's see. So we save the tiles sparsely, but every room is saved. Should rooms be created only when the player comes closer to them? So I kind of answered this on a previous stream, but I'll mention it again. Because there's something that you should understand. This is a very fundamental concept in programming, actually, to understand. And that is the concept of best case, worst case. So let me just take a minute, because it's exactly what you're asking about. I want to take a minute to describe best case versus worst case and why you have to care about the difference between those two. So, a lot of times people make the mistake of trying to optimize for their best case. But really what you mostly want to do for game development is you want to optimize for your worst case. What does that mean? Well, I'll give you a simple example from first-person shooters because these make this is sort of a good example of when you care about it. Let's say I am making a game that's a first-person shooter, and I'm talking about a time when the player is here and they're pointing this direction. This is a top-down view, and there's a wall. They're looking right at the wall. So the thing that they're going to view, right, is in their first-person view. This is looking straight ahead. Here's their little gun. The thing that they're going to view is a wall. right? And somebody looks at this and goes, there's all this stuff back here in this other room that's behind the wall, whatever, and there's all this stuff, there's people walking around, and I'm like, wow, we're spending a lot of time, because we rendered all this stuff that was behind the guy, only to then draw a wall that was behind, all the stuff that's behind the wall, but only to draw this wall and you can't see any of it, right? Wouldn't it be nice to write some occlusion code that says, oh, I'm looking at this wall, so I shouldn't draw any of this stuff. I should just skip it and draw the wall, right? Well, that's a perfectly reasonable thing to do. But what you have to think about is the fact that a couple seconds later, right, the player moves over and they're looking through a doorway into that same room. Like, here's the doorway, so they move over this way and they're looking into the doorway, right? And now they're seeing everything that's in that room, right? So basically, all you've done is save a little bit of overdraw in this case if you spent a lot of time doing that optimization, right? And you have to be aware that what you were essentially doing here is you were optimizing for your best case. Your best case is staring at a wall where you can cull out the rest of the room. Your worst case is going to be something like the guy is standing on a veranda and looking out over an entire planet, and there's mountains in the background and a giant sun that's peeking out and trees and all this stuff and tons of people walking around in here. That's your worst case, because there's nothing occluding anything in here, right? And so you kind of need to focus on this, which is this thing here, when you're talking about how you're going to optimize. And you have to talk about lots of level of detail and things that you're going to have to do that can't just be about looking for the one time that you were staring at a wall and going, oh, I can really optimize that case and get the frame rate up. Because it never matters what your best case frame rate is. The player doesn't care what your best case frame rate is. They care what your worst case frame rate is. They care when you come out here and you look at this and everything falls apart. It all goes pear-shaped and you're super slow, right? So how does that apply here? Well, basically what's happening is, let's say in our game we want to have destructible environments or whatever, right? So I've got this room, and the thing that I was just talking about, let's say we want to have a boss monster that breaks through walls, right? So I've got this room and I've created it, right, and I've done this thing, and now we know that sometimes there's monsters, and maybe they're not even boss monsters, they're just monsters that can shoot through a wall, and now the wall is destroyed, right? Well, if you base your entire scheme, the way that you're getting your storage efficiency or whatever, is that rooms only exist when the player walks into them, then what do you do when you start modifying the rooms? You've got to store that data somewhere. So now you've got a case where every time there is one of those monsters and it does the break through the wall thing, now you've got to store those rooms and you're not storing the other rooms. What that means is, in the worst case where you have a world filled with those monsters that are destroying things, you've now gone from having to store no rooms to having to store almost all the rooms, because you've got to store all of that damage that occurred there. And think about it, adding things on top of that. Say you want to write in footsteps. Say you want to have people be able to burn things. Say you want them to be able to push things around. Say you want to be able to have them to create new trees with a spell, whatever. You've gone from, again, you're focusing on the best case, which is the case where rooms don't get modified. And that's not the case I care about. I care about our worst case. I want to make sure this game works well for games, when in the game design we're going to allow the player to have a lot of mutability, to have rooms have a lot of effects on them, to have a lot of things that happen in them. That's really more what I'm concerned about. So I want to start by saying let's focus on that. Now, if we get to the end of the game and we find that that can never happen, like you just don't ever change the geometry of a room, hardly ever, then maybe it would be a good case to start thinking about that. But I don't want to design the engine up front around the best case, because then it will all fall apart if we decide that the design actually needs that worst case. So I'm focusing on this for now, and we can always optimize later if we find that actually our game is mostly in the best case scenario. Let's see. Are you worried about memory leaks yet, or do you... We answered this question on yesterday's feed. How could we have a memory leak? We haven't allocated any memory. We can't have a memory leak, right? So I'm not sure what that actually means. We're putting all of our stuff, our world map is in permanent storage. We will flush that permanent storage when we're done, so we literally can't have a memory leak yet. So it would be kind of crazy to worry about something that literally cannot happen yet. So no, I'm definitely not worried about memory leaks. Are ternaries bad? I see places where you could use them but don't. No, I use ternaries. They're totally fine. Sometimes I just think they're a little harder to read, but no, in fact, we've already used ternaries in the code in certain places, I believe. So the ternaries are totally fine. If you want to use them, go for it. I do use them fairly frequently. Let's see. Okay, getting to the end here. Let's see. Why is it not possible to save the full map? Okay, I think this will be the last question. Why is it not possible to save the full map? Megatexture did this too, didn't it? So the answer is we could save the full map, but we couldn't keep it in memory. So for example, Megatexture is a good example. Megatexture would not fit in memory most of the time. Like the whole point in Megatexture is you're paging it in and out from disk, right? So basically, assuming that we want our map to fit in a reasonable amount of memory, we can't. We have to store it sparsely, and also we just don't want to waste all that space. For the most part, saving things where there isn't anything just seems kind of wasteful in general. But yeah, if you want to do Megatexture, you're talking about an off-disk scheme. So that's kind of saying like, okay, we've got a 4 billion by 4 billion thing, right? And so if you wanted to save that, let's see how big that would be. I mean, even that you wouldn't be able to really save the whole thing, right? So that's 4 times 10. Oops. 4 times 1024 times 1024 times 1024 equals this, and that's squared. So that's that big. That's how big that is. And now, if you want to know that in, say, terabytes, we can divide by 1024. Oops, that's no good. Well, actually, I guess we can just do this in gigabytes. So that's 4 gigabytes by 4 gigabytes, right? Would that be an accurate statement? So I think, is that correct? Yeah. So it's basically 16 times 4. So this would be 64 gigabytes. I believe, to store 1 D word per tile, which we're probably going to want to store a lot more than that. But even if we just stored 1 D word per tile, that would be 64 gigabytes, I believe, if I'm doing that math correctly. So basically 64 gigabytes, nobody has that much memory in their machine these days. Eventually, maybe they will, but not right now. So you'd basically be talking about storing 64 gigabytes of data on disk, and then paging it in and out. You'd probably try to compress it maybe on disk as well, I'm not sure. You'd have to store 64 gigabytes, you'd have to page it in. Since it's procedurally generated, that means you would be writing 64 gigabytes of data at startup of procedurally generated stuff. How long does it take to write 64 gigabytes? Well, I think hard drives write at something like 500 megabytes a second. That's 2 seconds per gigabyte. So you're talking about 2 minutes of startup time just to write your game world to disk. Just not looking promising, right? So I think it's pretty much safe to say you're never going to want to do this in a procedurally generated game. You really do not want to store the full map if it's going to be something large. You want the sparseness because we're not going to actually have a 4 billion by 4 billion world because the player could never walk through it. It's going to be something much smaller. So basically we want to just focus on storing what we actually use and not storing all the rest of it so we don't have this huge data management problem that we don't really need to solve, if that makes sense. All right, so I think that's it for today. I think that is about it. Am I wearing my earphones backwards today? Yes, I am. I actually am doing that. Oh, and that's right. I forgot. Someone was just mentioning on stream. When I did that math, I actually totally forgot that we have multiple planes too, right? So it wouldn't be just. It's not just 4 billion by 4 billion. It's 4 billion by 4 billion by how many Z slices we wanted as well. Right? If we weren't storing it sparsely, right? So it's going to be 4 gigabytes. It's going to be way bigger than that. In fact, it's going to be 4 times 1024 times 1024 times 1024. And yeah, I forgot to do the gigabyte squared, so that's even the wrong calculation. I did that calculation wrong. So this is how many tiles there are across. We square that to get the total number of tiles, right? Where's the square button? Square it, that's the total number of tiles. Now, how many Z slices do we want? Let's say we want, 16 Z slices at least, right? So 16 Z slices. That's how many tiles we have total, right? So now, if we copy that number, right, we're going to divide that number by, let's say, a gigabyte, right? So that's a gigabyte. So this is actually the number. I was way off. I forgot to square gigabytes. I did 4 times 4, but I forgot to square. You know, I did 4 gigabytes times 4 gigabytes. I did 4 times 4, right, which is 16, but I forgot to square gigabytes. So that's gigabytes squared, right? Does that make sense? So I forgot to square gigabytes. So now I've squared the gigabytes. Looking at it's way worse, right? In fact, let's go ahead and change that to terabytes. Now we're talking about 268 million terabytes. So you couldn't even store that on a drive. There's no such thing as a 268 terabyte drive. So yeah, so forget about it. Like whole world storage at those dimensions just isn't going to happen. All right, I think we've come to the end of the questions. So thank you everyone for joining me, Handmade Hero Day 35. It has been a pleasure coding with you, as always. We are basically finished up our tile map stuff, our tile map storage stuff. So we kind of know now, at the end of Day 35 here, we kind of know what we want our engine to do for tile map storage. It's kind of pretty, I think it's laid out reasonably well, so we'll be able to write this pretty cleanly. We know the sort of stuff we need. So we can start moving on. I think next week we'll add our little up and downs just so we can have them in there. But I think next week we'll be ready to move on to something else, so that'll be good. Maybe we'll start to think about how we're going to render the tile map graphics, so the stuff on top of there. Maybe that's what we'll do next week. I'm not sure. I'll have to think about what I want to do next week, what's the most important thing to do. We've also got player motion to think about. We've got monsters to think about. So we've got a bunch of things that we need to do. But yeah, so a bunch of things to think about. I'm not sure what we'll do next week, but please, if you enjoyed the series, please think about joining us for whatever we do decide to do next week. I promise it'll be interesting. We'll be doing it Monday at 8 p.m., our standard slot, Monday 8 p.m. Pacific Standard Time. So please come back for more game programming. We would love to see you here. If you would like to follow along at home with the source code, it is available. Anyone who pre-orders the game, let me go ahead and close this down here. Anyone who pre-orders the game on handmadehero.org gets instant access to the source code. You can go on and download everything. I update it every time immediately after we finish work. For the day, I upload it so you can play around with it yourself, learn from it, and do whatever sorts of things you want to do to sort of learn game programming inside the context of the Handmade Hero source tree. So if you want to pre-order that, you can download that, and again, it's updated every day, so you can download it afresh and keep track of where we are in the series. If you just want to support the video series, we do have a Patreon you can subscribe to, so you can head on over there. And if you're trying to learn from the series, there are a lot of additional resources you can use at the news and forum site. If you click through there, there's all kinds of stuff, episode guide, a discussion forum, the schedule's posted there, usually on Mondays. There's ports to Mac and Linux if you're interested in those. So there's all kinds of good stuff there, so please check it out. If you're trying to learn from the series, it's a great place to go. Thank you, everyone, for joining us. We will be back here Monday, 8 p.m. PST. It's been a pleasure as always, and I hope to see you there. Thanks, everyone, and have a good weekend.